Hello dear students, in this class we are going to discuss previous year's definite integration problems. Let us see here. First question, 0 to pi by 4, integration 0 to pi by 4 log of 1 plus tan x dx. So let us consider this is I, okay? Question I am considering I. So whenever we have 0 to a form, integration 0 to a f of x form, we have to apply the property, okay? 0 to a f of x dx is equals to 0 to a f of a minus x dx, okay? This is the property we have to apply here. So x is changing to a minus x. In the place of a we have pi by 4. X is changing to pi by 4 minus x. So from here I is equals to integration 0 to pi by 4 log of 1 plus tan of pi by 4 minus x whole dx. So here we can write it here 0 to pi by 4 log of 1 plus here tan of a minus b, tan a minus tan b by 1 plus tan a tan b, okay, whole dx. So I is equals to 0 to pi by 4 log tan pi by 4 is 1, tan pi by 4 is tan pi by 4 is 1. So here 1 plus tan x LCM is 1 plus tan x. So 1 plus tan x plus tan pi by 4 is 1 minus tan x whole dx. So this is plus tan x minus tan x cancel. I is equals to 0 to pi by 4 log of 2 by 1 plus tan x whole dx. So log m by n formula is log m minus log n. So this is the formula. Log m by n is log m minus log n. So I is equals to 0 to pi by 4 log 2 minus log 1 plus tan x dx. So separate the integration, okay? So I is equals to log 2 into integration 0 to pi by 4 1 dx minus integration 0 to pi by 4 log of 1 plus tan x dx. So what is this actually? This is I. The question itself is I, right? This is I. So in the place of this I'll write I is equals to log 2 into 1 integration is x from 0 to pi by 4, and this is I. Send this I to the left side. I plus I is 2i. So log 2, this is log 2 into upper limit substitute. Upper limit pi by 4 minus lower limit is 0. So 2 times log 2 into log pi by 4. So 2 send it to right side. I is equals to 4 2s are 8 by 8 log 2. This is the solution. Okay, this is the solution. That's all. So here we have second question, 0 to pi log of 1 plus cos x dx. So let us consider this is the question. I is equals to 0 to pi log of 1 plus cos x dx. Now apply the property, okay? So 0 to a f of x dx is equals to 0 to a f of a minus x dx. This is the property we are applying here. So here x is changing to a minus x. Here in the place of a we have pi. So x is changing to pi minus x. Now we will change. I is equals to 0 to pi log of 1 plus cos of x. In the place of x we have pi minus x whole dx. So 180 minus theta, pi minus theta lies in which quadrant? Second quadrant. Second quadrant, cos is negative, okay? Sin is positive, cosecant is positive, remaining all are negative. So cos is negative, so you can write it here. I is equals to 0 to pi log of 1. Because of pi minus theta, negative cos minus, because of pi, cos remains cos x dx. Okay, now this is equation before applying property, equation 1, after applying property, equation 2. Add 1 and 2. Okay, 1 plus 2. If I add 1 and 2, left side I plus I is 2i, integration 0 to pi log. First equation is log 1 plus cos x dx, 1 plus cos x dx. Second is plus log of 1 minus cos x dx. Okay, so 0 to pi. So 2i is equals to 0 to pi. So log of 1 plus cos x d, no need of dx, I'll write together, plus log of 1 minus cos x dx. Okay, so your log m plus log n, log m plus log n, formula is log mn. Okay, log mn. So apply here the formula. 2i is equals to 0 to pi log 1 plus cos x into 1 minus cos x dx. So a plus b into a minus b, a square minus b square, right? 2i is equals to 0 to pi log of a square minus b square. So 1 minus cos square using first identity trigonometry sin square, right? 1 minus cos square theta is sin square theta. This is identity. So 2i is equals to 0 to pi log 1 minus cos square is sin square x dx. 2, here we have power 2 goes to the base because of log. Okay, so 2i is equals to 0 to pi 2 into log sin x dx. So this 2 cancel. So I is equals to 0 to pi log of sin x dx. Okay, so 0 to pi log sin x dx. So what am I supposed to do here? So we will go with the property, right? We'll go with the property. Whenever we have 0 to pi f of x dx, 2 times of 0 to pi by 2 f of x, if f of pi minus x is equals to f of x. Okay, if it is not equals, f of pi minus x is not equals to f of x, then we can say this is the result is 0. Okay, this is the property. So now I'm applying here the property. Okay, so let us consider inside a function f of x. F of x is equals to log sin x. So apply in the place of x pi minus x. Pi minus x is equals to log of sin of pi minus x. So pi minus theta lies in second quadrant, sign positive, because of that reason you'll get the same log sin x, which is f of x. This is f of pi minus x. F of pi minus x is equals to f of x. So this is 2 times of 0 to pi by 2 f of x, right? So we can write here I is equals to 2 times of 0 to pi by 2 f of x is log sin x dx. Okay, now we will apply the property same. 0 to a f of x dx is equals to 0 to a f of a minus x dx. Okay, this is a property. Apply. So I is equals to, here x is changing to a minus x, in the same way x is changing to a, in the place of a we have pi by 2 minus x. So 2 times of 0 to pi by 2 log of sine of, in the place of x, pi by 2 minus x dx. Okay, so I is equals to 2 into 0 to pi by 2. Because of 90 minus theta first quadrant, sine changes to cos because of pi by 2. So log cos x dx. Okay, before applying a property, let us call it equation 3, After applying property, call it equation 4. Okay, equation 3 and 4 added together. Okay, 3 plus 4. If I add this, left side I plus I is 2i, and this is, so 2 take common, and here 0 to pi by 2 log sin x plus log cos x whole dx. So log a plus log b, log ab, right? So we can write this 2 cancel. I is equals to 0 to pi by 2. We can write together log of sin x cos x dx. So from here, sin x cos x, whenever we have, try to make 2 sin x cos x, so we can write sin 2x. Okay, we can write sin 2x form. So let us consider multiply 2 divide by 2. So numerator sin 2x form, right? I is equals to 0 to pi by 2 log of sin 2x divided by 2 dx. Okay, so we have once again the form I is equals 0 to pi by 2 log a by b is log a minus log b whole dx. Okay, so from here we can write I is equals to integration 0 to pi by 2 log sin 2x sin 2x minus dx minus integration 0 to pi by 2 log 2 dx. So from here we can write this part assumption now. Let 2x is equals to t. Differentiation of x is dx. In the place of dx we can substitute dt by 2. 2 goes to right side, dt by 2. And in the place of lower limit, in the place of x substitute 0. Then in the place of x 0 substitute t is equals to 0. The same way upper limit x is equals to pi by 2. Then t is equals to pi, right? Substitute in the place of x pi by 2. So pi. So this is too lengthy, but still. So here pi, you can change the limits to this question, right? So I'm changing here limits. I is equals to integration 0 is what? 0 only. In the place of pi by 2, in the place of pi by 2 upper limit pi, right? In the place of this log sin t dt by 2, right? dt by 2. So 2 goes outside, minus log 2 integration of 1 dt dx is x, right? X from where to where the limits are 0 to pi by 2. So here I is equals to 1 by 2 outside, integration 0 to pi log sin t dt minus upper limit is pi by 2 minus lower limit is 0 into log 2. So here I is equals to 1 by 2, and this part, see here, this is variable, and 0 to pi. So sine variable integrating with respect to same variable 0 to pi, we have what actually? So here look at the carefully the equation. So 0 to pi, where we have 0 to pi log sin x dx. Okay, 0 to pi log sin x dx. That means here 0 to pi log sine variable integrating with respect to variable. What we have? I, right? We have to write I. Okay, in the place of this term. In the place of this term, we have to write I. So I minus pi by 2. This is pi by 2 into log 2. So send this term to the left side. I minus 1 by 2. This is 1 by 2 I. Okay, I minus of I remains is equals to minus pi by 2 log 2 is the, so here 2 cancel, I is equals to minus pi log 2 is the answer. This is a solution part. This is too lengthy, but this is a kind of questions very important.